by how much she goes up for every mile. So in Gilberto's example, he went up $2 for every 1 mile he walked. He went up $2 for every mile, up $2 for every mile, up $2 for every mile. So how steep this line is, that's what we call our slope. I can also see it in the table by adding 2 every time. So I add 2 for every 1 mile that he walks. I add 2 for every mile, I add 2 for every mile. Okay. The other big idea, where I start, that's what we call our y-intercept. Okay, so where I see that on the graph is Leanne, when she started, she was at 10. So regardless of anything I put in here, 0 times for distance, I'll get out 10. For Gilberto, 0 times 2 is just 0. He started at 0. And Elena started at 5. So in my table, it's that starting value of wherever I see something at 0. Okay. So my independent variable is what I put in. In this case, it was my distance. That's where I can find my slope. So it tells me how much it is per mile, because what I'm getting out, my dependent variable, is my money raised. So every time I'm putting in distance, however much that goes up every time, that determines how steep my line is. We call that our slope. It's how much my table is going up every time, and then we can see that in our graph. It's going up 2 every time. And then my y-intercept is simply where I start. So if Gilberto started at 0, I plus 0, not necessary. But let's say Leanne, if she starts at 10, I need to include that plus 10 in my equation. So regardless of this distance, Elena's starting at 5, Gilberto starting at 0, and Leanne started at 10.